We are doing section 8.4, which is scientific notation. And I want to remind you that scientific notation is written in a particular way. You have a constant, which is represented by the C, times 10 to a power. That n is your power. The constant that you have is always some number between 1 and 10. So it can be equal to 1. It's greater than or equal to 1, but it's less than 10, meaning it's one digit in front of the decimal point. Can there be other digits behind the decimal point? Absolutely. But the number in front of the decimal point has to be some number between 1 and 10. That's why it's 1.25, 6.79, 9.99. Is that less than 10? Absolutely. N is always an integer. It can be positive or negative. This is the one time that you're going to be allowed to have negative exponents in your answers. Scientific notation can have negative exponents in the answers. Okay, remember when we talked about negative exponents the other day, I said, for today's homework, you're going to have all positive exponents. Okay, that was just 8.3. But in terms of scientific notation, you can have negative exponents. Why are we doing this? So we know how to write numbers in scientific notation. It allows you to better manage extremely large or small numbers that have lots of zeros. For example, the number of electrons that pass through a 1 amp circuit every second is 625, followed by 16 zeros. That's a really big number, isn't it? It is easier to write that number in scientific notation in order to determine how many electrons pass through that circuit in 60 seconds. Okay? Getting into some physics, getting into some advanced pre-calc type and AP Calc type information here. Now we're going to just write this number in scientific notation. Okay? Could someone read this number for me just mathematically? Read it, Adam.
267,500,000.
Exactly. 267,500,000. Now, jot down what you think it is in scientific notation, and then we will have some talk about what do we do here. Because I know you guys have had scientific notation before. That should have been taught to you in 7th and 8th grades. So I know you should have had it. If you've never had this before, well then please listen as to what's going to go on. Who can tell us what we should be doing here along the way? What should we be doing? Rachel?
You move the decimal point over 8 spots to the left.
Okay.
And then it becomes 2.675 times 10 to the 8th power.
2.675 times 10 to the 8th power. How did you know 8?
Because there's 8 spaces that you can move.
Alrighty, so she picked up her decimal point, which is sitting on the right-hand side, even though we can't see it, and moved it 1, 2, 3, 4, 5, 6, 7, 8 places until she now has a number that's between 1 and 10. 2.675 is somewhere between 1 and 10, times 10 to the however many places she had to move the decimal point to the left. Is this number that we started out with bigger or smaller than 1?
Bigger.
Bigger. Thus, when we start out with a large number, a number bigger than 1, and we write it in scientific notation, we will always have positive exponents. Questions there? Is this number bigger or smaller than 1? Oh, we're starting out with a number smaller than 1. What do you think about the exponents here?
Negative.
They are going to be negative. Would you write this in scientific notation? That's some knowledge some of you probably came in with, which is wonderful to have. Write this in scientific notation and describe to us how you did that, please. How you did that. What do you say, Luke?
Like the answer?
Tell me about the answer, yes.
It's 4.86 times 10 to the negative fourth.
4.86 times 10 to the negative fourth. How did you get there, Spencer?
Luke.
Spencer, Luke. Luke, I'm sorry. I even said it right before. I'm sorry, both of you.
I just moved the decimal place over to the right 4 spots, and since I was moving it to the right, it's negative.
Because you started out with that number that's smaller than 1. If we look at this 4.86 times 10 to the negative 4, that's really 4.86 times 1 over 10,000, isn't it? That's really 4.86 divided by 10,000. That's going to make that small number that we started out with. That's why we get to have negative exponents there. That is so awesome. That's right. So most of you probably knew how to write those in scientific notation already, didn't you? You're not, oh, I can do that part of it, right? Hands down. That's the easiest part, right? Okay. How do you know if the power of 10 is positive or negative? How do we know if it's positive or negative, Jack?
Which way you move the decimal.
Which way you move the decimal, okay. Jake?
We'll have a negative sign in front of it.
Now, how do you know whether to put a negative sign is what I'm asking.
Well, if it's less than 1 or greater than 1.
Okay. So if the original number is greater than 1, we're going to have the power be positive. If the original number is between 0 and 1, meaning it's a decimal, the power is going to be negative. Write this number in standard form. Jack?
What if the number is negative?
Negative numbers in scientific notation. You still are writing the number. It's between 0 and 1, the absolute value of it being between 0 and 1, then you just put the negative sign in front. I don't know that I've ever seen a number in scientific notation that's negative. But I'm sure they're out there. I'm sure they are. Maybe I just don't even think about that, and then I work with it all the time. Write in standard form, please. What is this number going to look like along the way? Josh, what do you say?
702,340.
702,340. Describe to us what you did, Josh.
I moved the decimal point 5 places to the right.
To the right?
Yeah.
To the right, to the right. All right. And how'd you know to move 5 places?
Because that's what the exponent is.
That's what the exponent is. And how'd you know to move to the right?
Because it's a positive exponent.
Because it's a positive exponent. I'm taking this number, 7.0234, and I'm multiplying it by 100,000. Don't you think your number should get bigger? Use your common sense, please, on some of this. And I know some of you are looking up here going, we know this. Good. I got to make sure everybody does. Next one, please. Write this number in scientific notation. I mean, standard form. Jake got me on. Write this number in standard form. He had me switch my markers around because I had them in the wrong place. He doesn't want me writing in blue when I'm holding a red. Sometimes I like to be a rebel, Jake. I know. Right, the standard form. 3.09 times 10 to the negative 8th power now. Negative 8th power. Right, what's it going to look like? What's it going to look like? Michael, what do you say?
I got 0.000000.
Okay, how many zeros should I have up here?
7 zeros.
I got 6. I got behind you. 3 what?
3 zeros.
Okay, I got behind you just a little bit. My pen didn't write as fast as you thought. How did you know to do that?
Well, because it's negative, we move it to the left. Decimal place to the left.
All right, we're going to pick up our decimal point and move it to the left. 8 times 1, 2, 3, 4, 5, 6, 7, 8. Right on the edge there. Any place that you create, what do you have to put in it?
0.
A 0. Does anybody want to try to read that number off mathematically? Talk to your partner real quick. See if you guys can come up with that number mathematically being read.
Tens, hundreds, thousands, 100,000.
I don't know after the millions how they're said. No, like is it 10 millions, 100 millions, or is it one billion?
So, Adam, you want to try?
Yeah. Okay. I'm going with 3,096 billion.
3,096, first of all, reading the numbers that are here. No problem. Now, you said 100 billions?
Yeah.
Okay, let's figure out if it's 100 billions. How many places are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
10 billion.
I got to look at this place value. What number has 11 zeros after it? That's 6, 7, 8, 9, 10, 11. What number has 11 zeros after it?
That's 100 billion.
This is a million. This is a billion. This is 100 billion. So it's going to be 3,096 hundred billionths.
Wow.
You got to read the number, and then you got to look at the place value of that last digit. And you got to know how many zeros, how many places you're out here, and that's how many zeros are in the whole number. Okay. We'll work more with that tomorrow and reading those decimals. A little extra bonus. Good. Now we're going to do some computation with numbers and scientific notation.
Oh, I hate this.
Oh, Mr.
Stop.
Dayton.
Thank you. Stop. We're going to do this not using our calculator. So when you're multiplying, please notice it's all multiplication up here. And we should think about multiplying these two constants together, 5.7 and 2.6, multiplying them together. Could you just do that real quick on your paper for me?
14.82.
14.82. Do you guys agree with that?
Yes.
Okay. Times 10 to the, you have two 10 to powers. What happens when you take two bases that are exactly alike and multiply them together and they have exponents? What do you do to the exponents? You add them. So negative 3 plus 4 is?
1.
So I have 10 to the first power. Now, here's the deal. Is that number sitting up there right now in scientific notation?
No.
All right. So I want you right now to just look at the number 14.82. Forget about the times 10 to the first for just a moment. 14.82. Could you write that in scientific notation? Just that number. Okay, could I hear what that is in scientific notation? Evan, please.
1.482 times 10 to the negative first.
Not 10 to the negative first. What am I starting out with? A number larger than?
Oh, so it'll be 1. So
It's
then
going to be
every
10 to the first.
So then
Okay, and then we're going to bring this down here, times 10 to the first. Okay, so all we did was we wrote this number that was not written in scientific notation so that it was. And now I have to finish this up. This is going to be 10 to the, so I'm going to have 1.482 times 10 to the second power. Here's the deal with computation on scientific notation. You're going to do your constants as you always have. You're going to take care of your bases that are alike because they're all times 10 to and you're going to take care of their exponents as you always have. But in the end, your final answer must be written in scientific notation. So my little math help to you is to look at the number that's not written in scientific notation and go ahead and put it in scientific notation and then attach the rest of the times 10 and finish it up. Your answer will always be in scientific notation, Matt. Harrison?
148. Let's check with my calculator.
Oh, you took 5.7 times 2.6 and got 148.2?
Yeah,
Guys, check with your calculator. 5.7 times 2.6. Let's find out. Are we at 14.82 or 148.2? 14.82? Check out Harrison's calculator. Something's going awry. That or he's putting decimal points in the wrong spot. Okay. Are we okay? Did it work, Harrison? Okay. Need to figure out, because there should only be, you know, if you're looking at 5.7 and 2.6, we know the numbers are 1482 to begin with. I only have two places behind the decimal point. I should have two numbers behind my decimal point if something's not a zero up there. Okay, are we okay now? Fabulous. I didn't get to ones that are going to deal with some division and stuff. We'll talk more about those tomorrow. I do want to hand to you your worksheet